We are now recording.
So do we not have classes? And I guess I didn't look ahead on the calendar. Do we not have classes in May then? This course is finished at the end of April.
So in 2 weeks from now, we have our last in-session class. I'm still going to be available to meet if anyone would like to meet. I think the folks that have tried to find times to meet, it's been helpful. And so please, I recommend, I know that everyone's busy, but email me and ask lots of questions as we try to wrap everything up, whether it's for this problem solving journal, reflective journals, or the last ones, or even if you have a problem of practice that you're dealing with right now in your own context, just reach out. I'd love to chat. So tonight, we're going to take additive reasoning a little bit, one step further. So we did a bunch of stuff when we think about addition so far in this course already. We counted. And I had you all count to 1, 0, 0, 0, base 4. And that was how we kind of kicked off base 4. And there were some ups and downs. 0, 1, 2, 3, 1, 0, 1, 1, 1, 2, 1, 3, 2, 0. And we kept doing that. And that's kind of very much so just this rote counting exercise. And it's kind of, I liken that to kind of multiply or memorizing multiplication tables, memorizing the base 10 table that we did, or memorizing the base 4 table. And that's basics. That's something that we can do to kind of get some of the stuff out of the way so that we can spend our focus on the learning and the doing of mathematics moving on. So we did that. And that still, connects to additive reasoning, but it is kind of a very low level additive reasoning example, just counting. We kind of brought in our fingers or counters, which I highly recommend continuing to use. When we did that, we talked about the idea of one-to-one correspondence. And so when you all are working on that assignment for problem solving journal number 1, and you were doing your addition and you might have drawn circles or squares and you were counting them, right? You were assigning value to a thing. And that's that idea of one-to-one correspondence. From there, we started kind of doing adding, and we took 2 different numbers and adding them together. And we were counting blocks or counting all or counting on, doing that. And these are still very concrete things to do, right? You're looking at something, you're touching a block and counting it, you're putting little groups of things together. And so it's a very concrete way to think about addition, which is great and should be done. But some point when we think about students learning, we have to move from a concrete way of thinking about it to what we would consider to be a figural way. And what I mean by figural is that we have to kind of start thinking about the different places that exist in base 4 and thinking about a way to represent them. And this is where we come back to all that work that I had you do at the very beginning of this semester around M&Ms, right? You all created a figural representation of place value base 10. A lot of you said that the blues represented 1s and the browns represented 10s and the yellows and the oranges and all the different colors represented something. You started because you realized that as the numbers got bigger, that we couldn't just have a concrete example. We couldn't just have one M&M represents an M&M, right? Because we started running out of M&Ms and it started getting confusing. And I added all these extra constraints and said I could only subitize to 5, things along those lines. The same thing works when we get into addition. That's great for us to have counters, especially with the examples that you might have used in problem solving journal 1. That might have been 1, 4 base 5 plus 2, 1 base 5, right? You probably have enough blocks to do that. But what's going to end up happening is that we're going to get into 3-digit numbers or 1, 0-digit numbers. Right? It's going to keep growing and growing and growing. And it's no longer sustainable to be able to just you have one block represent a thing. And so students have to be able to move from that concrete way of solving math to a much more figural way. And so that's what we're going to spend our time on tonight. How do we move from concrete to figural? And I'm going to propose that we're going to have, instead of M&Ms, which would probably be really good with some chocolate right now, but we don't have M&Ms right now. Some of y'all might. But what we're going to do is we're going to actually create a figural representation here. And so what we're going to do is, if we're in the ones place, we're going to represent those numbers with a little circle. And I bet you all did a lot of that in problem solving journal number 1. You might have had like a whole, 1, 2, base 6. And so you made little circles to do that. In these examples, what we're going to do is we're actually going to say that all of the ones in base 4 are going to be these little dots or circles. So you can do 1 circle, 2 circle, 3 circle. But when you get to that next circle, we have to do I want to hear what happens. What do we call it? It is a
Unit transfer.
yeah, unit transfer, unit exchange. I love it. Thank you. When we do the unit exchange, we're going to represent it a little bit different. So you'll see here in this particular example that the 1, 0 base 4, we're going to represent as a stick. And then the 1, 0, 0 base 4s are going to be represented as a square. And then the 1, 0, 0, 0 base 4s are going to be represented as a big X. Things get a little trickier, right? If we do that. So I just kind of want to quickly show you, and then I want to have some questions, because I've been talking way more than I like talking and hearing my voice. Nope, that's not what I want to share. Can we see my blank page? Great. So let's say that we're doing counting. We do 1, 2, 3. Remember, we're in base 4. Should have said that. Come on, Dennis. We add 1 more of these. This is a group. This is a unit exchange. This is the next place. So what we're going to say is that if we have these in base 4, we're actually going to represent them like this. So we actually do a unit exchange. And we know that that stick there is the equivalent of 1, 0 base 4. And then similarly, we have 1 of those sticks. We have 2 of those sticks. We have 3 of those sticks. This is 3, 0 base 4. If I add another one of those sticks, that becomes not 3, 0 base 4, but 1, 0, 0 base 4. But we're going to figuratively represent that differently. Can anyone remember what shape it was that I said was 1, 0, 0 base 4?
Square.
Yeah. Square. So both of these are the same thing. But what we're going to privilege when we do this is to do the unit exchange and represent it as something a little bit more figuratively. I would love to hear 1 or 2 questions about that. Or thoughts. What did you notice?
I felt like that just made it more, like visually, it was easier to deal with that than it was all the little dots. Like all the little dots were really overwhelming. Whereas when you had one big image that was representing so much, it was less. Does that make sense? It was just less intense on the like visual, like taking it in. I could take it in easier.
I love that. Thank you. I would love to hear one other reflection.
It's easier to identify this way, but I am just like, okay, this is a perfect picture. What we have additional pieces to it. So how would that look like? So I'm trying to decipher that in my head. You know, one X, one line, or a dot, how would that look like? So I am thinking on those lines.
Yes, thank you for thinking about the next step. Are you just assuming, Sobia, that I'm going to make this more difficult soon? I see how it is now. Great. Those are really good thoughts and really good reflections. I'd like to kind of go over a couple of examples just to talk about and share ideas. And then we're going to go through, you'll see, I'm going to send you off into pairs and have you practice both addition and subtraction. So I'm going to do just a couple of examples to get us thinking. Question: would it be more confusing or helpful to do an example in base 10 first? Or do we just stay in base 4? Base 4?
Are we going to do a base 10 in Teams?
Probably not. We'll stick to base 4. We'll stay to base 4. Let's do an example. We'll do an addition and a subtraction. I'm going to share my screen here. Nope. Man, I'm picking the wrong thing. My brain tonight. So let's do 3, 2 base 4 plus 1, 3 base 4. And so when we think about it figuratively, probably one of the best things to do is to just draw these out using the figures. And so if we were representing 3, 2 base 4, that means that we've got 3 sticks, right? That's 3, 0 base 4, and we've got 2 dots. And then if we do 1, 3 base 4, we've got 1 stick and 3 dots. And so what I like about this is that this gives us a really easy way to start and think about the unit exchanges that exist or that we can do. So what I would do, I'm going to do this in a different color, is I would first take a look at the ones, that first place value. We've got 1, 1 base 4 of those, right? We have to do a unit exchange. So what I'm going to do is I'm going to take actually just 4 of those. I'm going to kind of erase. 4 of those, and I can replace those with a stick, right? And then how many dots do I have left over? I still have that 1 dot left over. So what I now have left over is 1, 2, 3, 1, 0, 1, 1 sticks and 1 dot. But we're not done, because we can do another unit exchange with those sticks. In fact, I can take exactly 4 of those and can anyone, again, remember what kind of unit exchange happens there? Those become a
Square to represent 1, 0, 0.
You got it. So we've got a square a line, and a dot left. And so, like you said, that's 1, 0, 0 base 4 plus 1, 0 base 4 plus 1 base 4. Or easier, you can just say it's one of the squares, one of the lines, and one of the ones. And that becomes 1, 1, 1 base 4. Fun stuff.
Okay, now I messed up. So
Okay.
I know you're saying one of each, but that stick is now throwing me off because when you represented all that one of each as 3 sticks with base 4 at the end, I'm confused because I was doing so good till then.
Okay, so were you good up until the fact that you see that we now have, so
Yep.
what we did was we took those 4 dots and we turned them into a stick.
Yep.
So we have 1, 2, 3, I'm going to use base 10 language, 1, 2, 3, 4, 5 sticks,
Yep.
right? So we have 5 sticks and then we have 1 dot left over.
Yep.
We can take 4 of those sticks and do a
Mhm.
unit exchange, right? So now
Yep.
we have a square, a stick, and a dot.
Yep.
Yep. So that
Mhm.
means we have 1, 0, 0 plus 1, 0 plus 1.
Yep.
Or one of those, one of those, one of those, which is just 1, 1, 1, base 4.
Yep.
That's it. Questions?
I don't have a question, but I don't know how I got to that answer, but I did not use your stick method.
Okay.
I just added them in a column similar to doing a base 10.
Great. That also works. The only way that you would lose points from me on that is if I specifically told you to do it using a figural representation like this. But if you have a way to get there, please go for it. And we're going to do more practice tonight. That's our goal tonight, is to practice on these. But I'm going to show you one subtraction example just so that we can think about it. And the subtraction example is going to be 1, 1 base 4, subtract 3 base 4. So I'm going to go through, I'm going to do my figural representations again. I've got a stick and a dot, and we're subtracting off 3 dots. Does that seem accurate? Does that make sense from what we've talked about for figural representations? Cool. Now, can anyone see a problem that we might run into? I see one. I want to see what do other people think?
So you can't take the 1 away from 3.
Yeah.
So you'd have to do a unit exchange back to create dots out of that stick you got over there. I don't know what that's called, but you have to.
Yeah. Do other people kind of see that? We're kind of running into some issues because we've got 3 dots on one side and only 1 dot on the other side. This is when we have to start thinking about breaking things up or doing a unit exchange, but going backwards. So I can rewrite this. How many dots fit into a stick? Or yeah, I like that. Melina shows me like the representation, which is another, like, again, that's that representation. That was really good. Right, we can break this up. This side can look like this: 1, 2, 3, 1, 0 of those plus 1 more, subtract 3. We had to break up the stick into its components of dots so that we can do the subtraction. And I like this method even more for subtraction than I do for addition. because it really gets you to kind of think about it and allows it to be a little bit easier. So we're going to take these away from those, right? And what are we left with?
2 dots.
2 dots. Oops. Or 2 base 4. And so what we're going to do, and I'm going to share this actually one more time, because what I'm going to do is I'm going to, come on. I'm going to take a screenshot of what we just did, and I'm going to throw those into the PowerPoint. Just as some examples. I'm going to put those in slide 5, folks, once that screenshot shows up for me. Okay, so those are in there. And this is what we're going to do. We're going to take, let's say, about 10 minutes. And I want you to just go through and solve as many of them as you can in 10 minutes. Try to do at least 1 addition problem and 1 subtraction problem. Try to get up into the triple digits if you can. But we're gonna go into groups. And I want you to just talk about it. And then we're gonna come back and we're going to ask lots of questions. I'm gonna create the groups here. Give me 2 seconds.
Is there any way for us to go to the groups that we are currently working with for the same themes, or would it be hard?
Oh, let's do it this way then. Good question. I'm going to set it up differently. I'm going to put a whole bunch of groups together, and I'm going to let you all join whatever group you would like to join. So if there were groups that worked really well together, let's create like 9 groups. And so those should be open now. So if you want to just kind of like talk or send a message to your partner, or just kind of jump into a group and hope that someone's going to join you, go and join a group. If you need help joining a group, or you want me to put you all in a group, I can do that too. And we'll take 10 minutes. I like this. Sylvia's using hand signals. And then if you don't have a preference, I can also just randomly throw you into some groups.
Dennis, how do you join a breakout room?
So can you find breakout rooms?
No.
Bottom. Is there a little like ... that says more? ...
That says more.
All right, go
Thank
to
you.
there and just like hop in a room.
Thank you.
Do folks who are left want me to put you into a room, or are you all just kind of hedging your bets and deciding?
No, I don't see a ... anywhere.
Was that you, Monica?
Yeah,
Yeah. How about I put you in a group?
okay.
Should be good.
You will have 11, 4.
We're back. How did that go?
Subtraction is making so much sense. It's no, addition is making so much sense. Subtraction, we're trying to figure it out. Addition is good. Addition is good.
Addition's good. Okay, that's good. I like that. Subtraction, you might want to do, might need a little work.
It's just decoding it and then breaking it apart.
Oh,
That
yeah.
we're trying to figure it out. Addition is going well.
That's totally fair. Other people feeling that way too? Oh, Susan's saying she gets the subtraction. Yeah, I can see both. I can see both, really. The addition, I like having that extra kind of connection, a way for us to do some larger numbers. The subtraction to me also makes sense. So I can see why both happen. Are there any questions that came up or anything that you'd like to go over?
I kind of enjoyed trying to figure it out. I mean, I thought it was pretty fun. And even though I feel like sometimes I don't know what I'm doing, I had fun even trying to figure it out, and I felt like I did well.
That's awesome. I love that. That's why I wanted to have a little bit of that time to just do and talk and be doing these. That's what these take. And we do have a whole bunch of examples here that I've written down that we can use and continue to look at as you go through and think about and practice and all that kind of good stuff. So what I might do, let's talk together through as a group 2 more examples, and I'm going to connect them back to some stuff that you all are probably pretty familiar with or remember doing at some point. So we're actually going to go down. We're going to go to slide 7. We're going to do an addition and subtraction problem. I am going to take us back into base 10. But what we're going to do is we're going to connect it to the algorithms that you probably have all used in the past. So you all have hopefully slide 7 up and running. I'm going to pull up my iPad. We're going to talk. So the first example is 1,789. Remember, we're in base 10 plus 2,351. And what I want us to do for a second is think about the algorithm that we've used to solve problems like this in the past. So can anyone either shout out or text out what's the first step y'all would do? It doesn't help that that's like a terrible looking 9.
They're gonna take your 9 plus 1.
We're going to do the 9 and the 1. And what
But
we're
this
going to
is
do
where
is
you
we're gonna-
don't like us to say carry the 1, but that's what I would say in the past.
Yeah, I
We're gonna
know.
make a unit exchange.
We're going to make a unit exchange. So we have 0 1s left, and we're going to bring a 1 over to the 10s space. Yes, I love it. Then we're going to do the same thing again. We're going to do 8 and 5 gives us 13, plus 1 gives us 14, but that's not the number 14. That's actually 14 10s, right? That's going to be helpful in a minute when we're thinking about the figural representation. We've got 14 10s there. So we're going to leave 4 of the 10s there, and we're going to do a unit exchange and say that 10 of those 10s is actually 1 100. Can we see how this connects to figural representations a little bit? Then we're going to do 7 100s plus 3 100s plus 1 is 11 100s. So again, we're going to put the 1 100 there, and we're going to take that 1,000 or the 10 100s over there. And then we have 2 plus 2,000s plus another 1,000 plus another 1,000 gives us 4,140. And that's how I would describe that representation. And see, when we're no longer talking about carrying the ones, we're talking about doing unit exchanges to a different place when we go through and do that. And we can represent this figurally in the exact same way. If you remember, thousands were created by an X. 100s were boxes, 2, 3, 4, 5, 6, 7. 10s were ones, 1, 2, 3, 4, 5, 6, 7, 8. And 9s were dot. The ones are dots. So that's a way to represent that first number. The second number I would represent like this. Two thousands, 300s, 5 10s, 1 1. I am going to get rid of those lines so that it doesn't get confusing. Some folks are going to be like, well, it already is kind of confusing. And so we're going to go through and we're going to go through each one of those examples, each one of those each one of these places, and do the unit exchanges we need. That's one of those. That becomes a stick, doesn't it? 10 dots. So I'm going to get rid of those and turn that into a dot or into a stick. Now we have 1, 2, 3, 4, 5, 6, and 8, 9, 10, 11, 12, 13, 14. Again, that 4, right? So we're going to take 10 of those dots or 10 of those sticks. Whoop. Wasn't the best. And turn that into one of these. So we've got 0 1s, we've got 4 10s. Now let's go to the 100s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we've got one of those 100s left and 4 of those X's. So we get that 4,140. That was a big example. That was a really big example. But it gives you a sense of how do we do those unit exchanges? How do we go through and do that? I'd love to hear some questions. I'll put that back. And I'll take a screenshot of that too. Once it shows up. Any questions? Would it be helpful to see a subtraction example? We're going to go back and we're going to do the example from the sheet because the other one I think is going to get a little confusing and get a little bit big. And then we're going to just open it up to questions and talk about next steps because we're almost done, folks. So we're going to go back to base 4. And the example that I have is 3, 0, 1 base 4, subtract 1, 2, 2 base 4. So again, first thing I would do, represent things figurally. That's going to give us 3 boxes and a dot. We've got 1 box, 2 lines, 2 dots over here. Can we take 2 dots away from 1 dot? So we've actually got to do a pretty significant unit exchange here. We've got to take one of these and break it all the way down. And I'm going to do that very super duper slowly. So the first step, we're still going to have go away. We're going to have 2 of these. I can break up that square to 1 0 sticks and a dot. We're still subtracting it like this. We're still in trouble, right? We still can't do the thing that we need to be able to do. So what I've got to do is I've got to break down one of these sticks. So I'm going to write it again just one more time differently. We've got 2 squares, 3 sticks, but now we have 1 2 3 1 0 1 1 dots, and we're still subtracting it from this. But that should be pretty much all of the unit exchanges that we need to do. So I'm going to do this in green. I'm going to take 2 of those away from 2 of those. I'm going to take 2 of these away from 2 of these. And I'm going to take, nope, I'm not going to do that. I'm going to take 1 of these away from 1 of these. And what we're left with is 1 of the 100s, 1 of the 10s, and 3 of the 1s. Base 4. So now what I'm going to do is I'm going to add those as well to our slides. And I have a recommendation, a thought. So I know one of the things that you all have to kind of think about is your reflective journals for next week. What I would also think about doing before we meet again in 2 weeks is to look at those other examples on slide 3 and just practice a little bit. And if they make sense, awesome, you're good. If you still have some questions, ask me some questions. And you'll have the examples that I've done in the slides within the next, hopefully, half an hour to an hour, depends on YouTube. I'll have this recording up in today's session, or you can come and just find a time to chat with me about it. And we'll go from there because our last session, we're going to talk about a whole bunch of things, but one of the things we're going to talk about is problem solving journal number 2, which is up and running. And it's going to be a combination of things that we've already done and some of the new things that we're talking about now. So the first question is just going to be, in base 8, list all the digits, which is something you did in problem solving journal number 1. Create an addition problem, solve it, explain all your steps. There's going to be another addition problem in base 5 where I'm asking you to add doing counting on or counting all. And then the very last question is a subtraction problem that I'm going to have you do it using a figural representation. So there are 4 questions there. I'm only asking you to pick 3. And I'm going to let you either work with a group for that, or if you want to do it on your own, because some people preferred that, you can do it on your own. So we'll do that. We'll change that up for this particular one. I'm going to give you all time to work on it and ask me questions to do it in class the next time we meet, which is the last time we meet. Thank you all for doing a lot of work tonight. If you have other questions, I can stick around and do that, or you can set up a time to talk to me. Otherwise, thanks and have a wonderful